Okay, let's look at some limits examples here. With any limit problem, you typically want to do is just take your limit value and plug it in and see what happens. None of these cases it's going to work, but it's just a good technique to always start off with. So 2 squared plus 5 times 2 minus 14 all over 2 minus 2, which is 4 plus 10 minus 14 all over 2 minus 2, which is 0 over 0. So whenever that happens, you need to do a different technique. In this case, we'll be using algebraic techniques, and for this one, we'll be factoring. So therefore, what are the factors of 14 that give me 5? That's 7 and 2. So I'm going to rewrite my limit statement. Factors x plus 7, x minus 2, all over x minus 2. Conveniently, these two cancel. So now I'm just left with x plus 7. So my limit statement is now just x plus 7. I now just take 2 and plug it in. I get 2 plus 7 is 9, and I'm done. This next one, as opposed to factoring, we're going to multiply this binomial here, and hopefully the x's, we got to get this x out of the denominator. Let's do direct substitution first, just to rule out that you need to do something other than just direct substitution. So plugging 0 in here, you just get 3 squared minus 9 over 0, which is 9 minus 9 over 0, which gives me 0 over 0. So that tells me you need to do something different. In this case, I'm going to square this like I said before. So x approaches 0. So this squared is just x squared plus 6x plus 9 minus 9 all over x. These two cancel out. So I'm left with x squared plus 6x all over x. I'm now going to factor this numerator here. Take out an x. Conveniently, what happens, the x in the denominator cancels, so these two cancel. I'm just left with x plus 6. Plug in 0, I get 6. So we'll try a different technique in the next one. And this problem here, again, direct substitution is not going to work, but let's just rule it out. I plug in 9, I get the square root of 9 minus 3 all over 9 minus 9, which is 3 minus 3 over 0, which is 0 over 0. So in this one, when you have a radical, a lot of times with limit statements, a good idea is to multiply by the conjugate, which in this case will be the square root of x plus 3. So the limit as x approaches 9 of the square root of x minus 3 over x minus 9. I'm going to multiply by the square root of x plus 3. And I need to use a property of 1, so I need another square root of x plus 3 in the denominator. I could multiply these denominators, but I don't want to. It just makes it a messier problem, so let's just rewrite the denominator as is. And we'll deal with the numerator in 2 seconds, as soon as I'm done writing this down. When I multiply these, the convenient thing about a conjugate is you don't have a middle term, so I just need to multiply the square root of x times the square root of x, which we use 9. 3 times 3, or negative 3 times 3 is, excuse me, that's x, not 9. X minus 9. What conveniently happens, these two cancel. I'm left with the limit, square root of x plus 3. Now I can plug 9 in, and I don't get 0 in the denominator anymore. I get 1 over the square root of 9 plus 3, which is 1 over 3 plus 3, which is 1/6. So in this one, we have limit as x approaches 1. By direct substitution, it's going to fail. 1 minus 1. Well, this is 1 over 1, so 1 minus 1. So this is 0 over 0. So therefore, I need a different technique. In this case, I'm going to multiply top and bottom, this numerator and this denominator, by the common denominator. Well, there's only one denominator in this whole thing, which is this x, and this complex fraction within a fraction. Let's get rid of this complex fraction by multiplying by the common denominator. So I multiply this and this by x, and then this x will go away. So then it'll just be easier to manage. Just a nice algebraic technique. So I'm just going to rewrite our limit statement. I'm going to multiply by the common denominator. I'm not going to multiply this numerator. I'm going to leave it as x and x minus 1. And when I multiply x times 1 over x, I get 1. And x times negative 1, I get negative x. Side note here, let's rewrite this expression here. I'm going to distribute this negative sign, negative x plus 1. I'm going to change the order, so I get 1 minus x. So these are all the same. Everybody's pretty comfortable going in this direction here, distributing a negative and then changing the order. That's fine. But let's just go backwards in this case. So therefore, let's change 1 minus x into negative x minus 1. So let's change the denominator to this expression up here, negative x minus 1, negative quantity x minus 1. So I get x minus 1. My denominator is now negative x minus 1. These two cancel. Now I'm just left with negative x. So let's go over here. Negative x. I plug in 1. I get negative 1. And I'm done. I think one more problem and then we're going to wrap it up. This limit expression looks pretty ugly, but it's actually pretty straightforward, provided you know the rule that anything to the 0 power is 1. So direct substitution is actually going to work in this case. So let's plug in 0 here. I get 2 to the 0 minus 2 to the negative 0, which is still 0. Likewise, the denominator is the same, except it's plus. So the numerator is 1 minus 1. The denominator is 1 plus 1. I get 0 in the numerator, 2 in the denominator. Well, 0 over 2 is just 0, so our limit is 0. And that wraps up our video on limits of algebraic techniques.